Okay, so I know I posted what seems like a million videos going over each individual section of chapter R, but I wanted to do a quick review. Okay, so this is only 11 slides, and it's just really highlighting like the key stuff we need to have down before moving on to chapter 1. So, friendly reminder, here is the real number. We have our counting numbers. We have our whole numbers, which are the counting numbers plus 0. We have our integers, which are the negative natural numbers, otherwise known as their additive inverses. We've got our rational numbers, and we've got our irrational numbers, okay? And all of these groups together make up the real numbers. These are numbers we'll encounter in everyday life and as we go through this course. When I'm taking the absolute value of a number, I'm measuring its distance from the 0 on the number line. We call 0 the origin of the number line. So when you think about it, distance is never expressed as a negative number, right? When I'm at work, I don't say I am negative 7 miles from home. No, I'm just 7 miles from home. So if I want to know how far negative 3 is from our origin, I'm going to go over and I'm going to say, oh, it's 1, 2, 3. It's 3 away from the origin, which is a positive number. Distance is always positive. The absolute value of 5 is 5. It's also important to know that we treat the absolute value bars like parentheses, so I need to simplify what's inside there first. So the absolute value of negative 4 is 4, and I've got a negative on the outside that I have to apply, so it's negative 4. And the absolute value of 0 is 0. Note that the absolute value is always positive unless it's got one of these sneaky little negatives hanging out on the outside. So let's go ahead and solve the following. I already have the solutions up, go me. But the absolute value of negative 5 is 5, and the absolute value of 4 is 4. So 5 times 4 is 20. Here I have the absolute value of negative 14, which is 14. And the absolute value of 7, which is 7. 14 divided by 7 is 2. Exponents are a whole number that indicates how many times a base number is to be used as a factor. So here's our exponent, right? It's going to be a whole number in this case. So this is saying I want to take 8 multiplied by itself 3 times. And this really comes in handy if I was, say, to have 10 to the 15th or 7 to the 17th, not only because these are really huge numbers, but do you really want to write out 15 tens? I think not. So this is our standard notation for an exponent. If I have 2 to the 5th, that means 2 times itself 5 times. If I have 3 cubed, that means 3 times 3 times 3. Here are some exponent examples. Friendly reminder, I can take fractions to exponents. So I've got 9 squared, 2 cubed, 3 to the 4th, 1/2 to the 6th power. This is how I'm going to say these in class when we're working through PowerPoints and taking notes. So knowing the correct terminology can be helpful to take your notes a little bit faster. Friendly reminder, 0. You can never divide by 0. You will break all of mathletics? What do I mean by that? You'll break all of mathematics. Let's not have a typo. You'll break all of mathematics. You can take 0 and divide it by a number. You're always going to get 0, but you can never divide by 0. It's undefined. So don't do it. You have been warned. Friendly reminder that the order of operations is PEMDAS, right? That's an acronym. It stands for parentheses, exponents, multiplication, division, addition, subtraction. You could use the mnemonic, please excuse my dear Aunt Sally. Maybe you learned a different one. If you did, I'd love to hear it. Friendly reminder, we really take care of our parentheses, we take care of our exponents, and then multiplication, division, addition, subtraction should really happen at the same time, working from left to right. That's as we read, correct? From left to right. So let's work through this example. I have 6 divided by 3 plus 2 cubed times 5. So no parentheses. I've got an exponent. Now I can go ahead and work multiplication division from right to left. Left to right. I'm a little directionally challenged. 6 divided by 3 is 2. 2 plus 8 times 5, that's 40. 2 plus 40 is 42. That's the meaning of life. If you don't get the reference, Google it. Okay, next I have 4 plus 3 squared. Because this has a big division in the middle of it, that's what fractions are doing. They're dividing. I want to simplify my numerator and then simplify my denominator. I've got 4 plus 9 over 6 minus 15. That gives me 13. 6 minus 15 would be a negative 9. So I have negative 13 ninths. For this next problem, there's a typo. Let me fix that. I'll replace it with a 2. So I've got this cube, negative 3 cubed. Remember, 2 negatives make a positive, but 3 negatives back to negative. So I have the negative of negative 27 plus a negative 5. I can just rewrite that as minus 5 over 4 minus 15. Negative 27 becomes a positive 27 minus 5 because this is like distributing a negative 1. 4 minus 15 is negative 11. So I have 22 over negative 11, that gives me a negative 2. Give you time to see that. A constant is a fixed, unchanging number, right? Like 1, negative 5/8, 2.35. An algebraic expression is a collection of constants, variables, operation symbols, or grouping symbols. So I have some constants, and then typically when we have a constant in front of a variable, we call that the coefficient. And we're going to be working a lot with algebraic expressions and algebraic equations, which are like expressions, but they have an equal sign between a couple terms. So let's simplify the following algebraic expressions by combining like terms. I have negative 2m, 5m, and this becomes a positive, right? So I have negative 2 plus 5, that gives me 3m, plus 6 is 9m, and 3 plus 8 gives me 11. Now this is fully simplified because I've combined all like terms. Here I got to go ahead and distribute. 3x times 5 is 15x. 15x times y is 15xy. Keep in mind we typically write our variables alphabetically. It's easier to keep track of, and that's the mathematical standard that you'll want to use in your online homework. For this next one, I've got to distribute twice. 4 times 3x is 12x. 4 times negative 5 is negative 20. Minus 2 times 8 is 8x. 2 times 7 is 14. So I got to distribute this negative, right? I've got 12x minus 20 minus 8x minus 14. So 12x minus 8x is 4x. Negative 20x minus 14 is negative 34. And there I have my fully simplified algebraic expression.